Hello, everyone. Welcome to the second day of our workshop. And today our topic is about customize your own model and the ways to train your own model and apply it on our LookX.ai cloud. And today, this lecture will be given by our COO, Xiaodi. And let's welcome him to give us this extraordinary lecture.
Hello everyone, and today I will show you some information about how you train your model on LookX platform, or even we'll talk about later about how to train what's the basic definition of the LoRA model and how you train your LoRA model on Web UI Extra. First, I will introduce you how what's the conception and what the LoRA model can do in the whole systems. Look at those pictures. This all generation based on our base model plus LoRA model, and it can generate different style of the drawing, architecture, or something else. The LoRA model is basically the idea transfer the style or the objects into a very small, tiny model, can multiply with the base model, can generation whatever you want. And here is some example on what LoRA model can do. You can see it can generate in the collage, and it can generate in the plan drawing, even some different kind of the curved shape architecture. It's all based on very limited picture you input, and we'll get the result immediately. So we think use LoRA model plus base model, you can get a lot of kind of possibilities. And how it works, it's just like the usual way we use the prompt to generation architecture, but we've add the LoRA model and give some special description, and you will get a result. And here is to show how you can use the LoRA model in our LookX platform. First, you choose the base model, and you can add the different LoRA model, such as the handmade model, and you will get the result of the handmade physical model or sketch, and you will get a sketch of the section and drawing, and even you can combine different LoRA models to get the combination result. And how you can get this kind of stuff, or even you can train your own model to get specific effect. So the next thing is we are talking about what is LoRA. First of all, and I will introduce 5 different types of model used in the web UI or used in the diffusion model, like the embeddings, hypernetworks, Dreamboot, LoRA, and LoCon, and Noricons. But the first 2 model is too old, and now they have little information about it. So we just start from the Dreamboot. And what Dreamboot do? And the Dreamboot will train the whole diffusion models and fine-tuning models with your own data on your own models. The pros of the Dreamboot model is it can use independently, and it can get the good balance between the original model and your data. But it can also have some disadvantages. First, the model size is very huge, and you need a very high VRAM graphic card, and because the model you cannot combine with another models, so it's less of the flexibilities. But in LoRA model, it comes with the Dreamboot model. It's like the plug-in, and you can also fine-tune your model with your own data. And the process, the model size is super small, and it's very easy to train, and the whole process is super fast. And like the video showed before, it can combine different kind of LoRA model to generate different kind of style. So it's have a very huge flexibilities. And also have the cons is the quality is lower than the Dreamboot. But for the for the start point to understanding the model training, I think the LoRA model is the best way we should try. And also we use LoRA model as in our platform to train our model. So today we'll talk about this one. And the fifth, the LoRa is a very new technology of the training model, but until now it's still not stable. So maybe in the future we can introduce these two kind of models a little more, but today we are focusing on the LoRa model itself. And what is LoRa model? The definition of the LoRa model is use a small amount of the data to train specific style or object to meet the customized requirements. The norm is the low rank adoption of the large language models and how it works, and it can change the style object by making small modification adjustments on a small part of the underlying models in the neural network. I'll give you a very small example, like this kind of hamburger. If the left one is basic model, it's like the bread, add meat, add bread, we compare a hamburger. But if in the normal model, we just add some bacon and vegetable, and you made your own customer hamburger. But the main point is it still contains the original structure of the basic model. So you just have add some styles or add some thing, but not destroy the original one. So this is basically what LoRa model do. So in our architecture model, like the left and the right one, we have the base style, but if we add like the feature style, like the model style, like the drawing style, it can do. And in this one, we still keep the original structures of the old model. So this basically how the LoRa model works. And how to train your own LoRa model. First of all, you should understand what kind of style can be trained. So in our platform, we can train in the like the elements, like the architect style, like the architecture style, things, material, and the environment. In this kind of things, you can train in the LoRa model one. So the step is like so first of all, after uploads your dataset and give some setting and training and test, and then you can use your model. It's quite simple. First of all, we will talk about how to prepare your dataset. There are several points of the dataset you should follow. The first one is the same style, but content have the diversity. This one is very important. First of all, you need to find several kind of the similar style of the image, and then you have to keep the diversity of the image, such like you have different kind of the proportion, you have different kind of the interior, exterior stuff, or even different kind of the buildings. So don't make all the pictures in one building. That's very important. Otherwise, you will not get the very good qualities. The second one is the image size should be bigger than 512 plus 512. If lower than this resolution, also will affect the final results. And the image number between 15 to 15. The fifth one is also very important. That is, the quality is much better than the quantities. So that means you don't need to find a lot of the pictures, but you have to make sure every pictures have the good quality to train. Here I'll give some data example. For instance, if we want training the concrete style, the data example is next one showing the screen. We have a different angle of the buildings in the different daytime, the nighttime, dusk time, and different kind of environments, the tree, river, extra in the city, or even different kind of the point of view, like the aerial view and perspective view, extra. So make sure all the pictures have kind of a diversity, but all the objects will keep the same target is concrete. And also, if we want to make the architecture drawing style, and also like the similar same, but in the drawing style, we'll keep the same drawing style, but in different kind of view type of the building, interior, exterior, etc. And this is one is the complex curved shape, also the similar one. So just remember the 4 crucial points of the data preparation is make the diversity, keep the same, and make the size and make the picture quality as good as you can get. When you have the data, you have to set in the parameters. So first, in our basic settings, you have to choose what kind of the model you want to train, such like the rendering, diagram, plan, extra, and other stuff. You have to choose the type you want to train it first. It will generate different kind of the parameters later. And the second is the trigger word. The trigger word is very important in the kind of the LoRA training, but in our system, we simplify this one. If you use LoRA, you will automatically trigger your trigger words. But if you want to combine different LoRas, you have to make sure you use our very unique words to use to ask the trigger words, such as if you want to use combine 2 different kind of LoRa's, the trigger word will not be the same. Otherwise, you will not get the result correctly. And in the advanced setting, they have several parameters is quite important. First one is training steps. The total training steps means how many steps the model will train. The more steps, the more features will be learned. But big number is not always fit your data set. That's very important. You cannot add a lot of a big number of the training steps if your data set is not fit. Like this kind of example, we want to train in this kind of collage drawing. We'll see in 500 steps, it will learn some kind of the drawing style, but not completely. But in 1,000 steps, it will generate this kind of collage drawing you want. But if you increase to 2,000 steps, it will generate something else. That means the numbers is bigger than you require. So you have to always test what is we call the sweet number is. Sometimes it's very difficult to say which number is good or suitable for your training. You have to try sometimes. But for my experience, first I always try big numbers first, like 1 or 2,000 steps, and to see if it's overtraining. And I will decrease the numbers several times to get the sweet number. And the second one is learning rate. The learning rate is quite similar than the steps. It refers to the steps size of an iterations. The higher number will learn features in no steps, but more blur. The lower number will learn the features in higher steps, but more precise. It's like the training steps. It's the same. It should not be too high or not too low. I'll give you example like the handmade models in the pictures. If we choose the number is 0.001 in the right side, you will see they learn this kind of model features, but in a very chaos way, and there's no details. It's just learning some kind of the key features. So that means your number is too high. But if you number into the 0.0005 in the left part, you will see it learning some kind of the features of the physical model, but still in reality environment. That means they are not learning enough. So we have to increase the number into the 0.0005 in the middle one. That's will generate the perfect results we want. So it's also need to try sometimes to get your sweet number to get the balance between the higher two numbers. In some case, it's always related to the steps before. So you have to keep the balance between the steps and the learning rates. Sometimes you need to change it several times to get the good result. That always happens in the model training. If you later on to train your own very complex model, this kind of steps will repeat once again. But this is a very basic idea to describe how you train your model and how this kind of how your models happens in a good result. The rest of 4 parameters is not as important one as before, but you can change a little bit to adjust the results as slightly different, slightly good or slightly bad. In most cases, just keep the default numbers as the platform gives you. When you train your data and you get results, and what kind of thing we can learn from your results is good or if it's not good, and what can we do? First, we have to check the data, like the one before. The data is very important for your training result. If you choose the data very randomly, like the one in the left side, it contains not so good quality pictures, not include so many good quality pictures. Output is not so good. And if we select the data very carefully and just keep the consistency and make the view and the other same kind of diversity, the output will increase immediately. And another one is we always have is overfitting and the underfittings. And sometimes if you train a lot, it will cause overfitting, or maybe your data sets is so similar in between each other. So that means your model will generate some kind of good quality pictures, but without change. So even you change your prompt, you will always get the similar result. That means the model is already overfitting. But then sometimes it's we'll have another situation is we call the underfitting. If you see the results is not fit to what you want, like if you want to train a physical model, but the result is nothing to do with the physical model, that means your model is not trained enough to get the result. What we want, or what we always want, is to try to keep the find a swing point between overfitting and underfitting. We call it optimus in the middle one. That means you learning all these kind of features you want, but you will keep the different type or different situation can use your models as well. So that means if you change your prompt, you will get a totally different result, but all you fit your original model what you want. So this is quite difficult in your model training, but this is our target, or say all these kind of model training targets wants to be. So in this kind of situations, we have a very simple way to change the results. Like if you find result is overfitting, the first thing is to check your data set. Just like I said before, just make sure you have enough diversity. You cannot put all the same information or all the same image to generation a model without overfitting. And the second one is reducing the training steps. Sometimes it works, sometimes not. It really depends on your data set. And the third one is reduce the learning rates, or even you try to change the numbers between the steps and the learning rates to find the sweet numbers. For the underfitting situation, it's a total complex way. First, you have to check the data set. Just make sure you can some sort of consistency. So you cannot put some concrete buildings and put some glass buildings or put some steel, metal, or otherwise buildings to train a concrete style. So you have to make some kind of consistent. And the second is increase the training steps. Sometimes you just need to do that way and you'll get a good result. But unfortunately, most of the time you have to check all the steps and change all the numbers to figure out what will miss to get the good result. In our platform, actually, we have a very simple way to do this kind of training style because we just simplify a lot of steps. First, you have to search in your data. And the second one, you just have some setting and start to train. And the third one, you can use a LoRA model. So actually, it's very easy, and you can try later to train your first training model on our platform and see what will happen. And will depend on the results to check out the parameter setting or other things. And the first one, if we have a huge number of the data, let's say is bigger than 200 or something, maybe our platform is not suitable for this kind of situation. You can also use the web UI to train your own model. And in this part, we are using the Dreamboot plugin to train your LoRA model. And here is quite similar than our platform. It also have some crucial parameters to change to setting. I have a very short description about it. If you later on, if you want to try this kind of thing, we can discuss. We can discuss what situation you have to change or what situation you want to do in the specific case. Here, I just to say some very important parameters we have to focus. First of all, also as the same as a platform, you have to change. You have to choose the training steps, the learning rates. This is for the computer stuff. If you have the powerful graphic card, you can increase the batch size to get the faster speed. And also like the platform, you have to change the learning rates, learning unit rating. And you put your data folders in the dataset directions. And you have to put your caption of your image as a TXT file in the same folder or the other. And choose a unique token. This is very important. Like I said before, the unique token always means maybe the first thing we have to do in correct way to make the result good. If you choose a very common tokens, that means you will totally destroy the original basic model, such as if you use building as a token. So this kind of a training step will totally change the structure of the buildings in the basic model. But in the basic model, maybe they have millions of pictures to build up the structures. If you destroy these kind of structures, you will get the very bad result as the final one. So you have to be very careful to choose the tokens in the web UI Dreamboot plugin training. And here I will introduce another thing is we call the classification visualization stuff. That means if you have too many pictures or so many pictures to learn and in a different kind of type or class, you have to make this kind of classification. That means if you want to generation a building, for example, for special buildings, you have to generation the buildings use the original basic models at first. Then the system will check the two different kinds of the buildings and to find what should follow and what should not follow. That will increase your final result very useful. So if you want to get the good results, you always have to choose the classification stuff. Here you have to set the classification folders and to choose how many classification pictures per instant image. It's sometimes it depends on how many pictures we have. If you have 200, 500 pictures, you can set 10 or 20 pictures per image. But you have thousands and millions of the picture, you can change this one into the 1 or 2 classification pictures per instant picture. And also you need have this kind of classification or visualization token that is similar than your dataset token. You have to name the special one. For example, if you want train your residential buildings, and the classification token should be the building. So that means you have the token and the one you want to training have this kind of structure. That means the classification means you want to train this kind of the building based on the building classification in the original models. And also you need to to have this kind of classification prompts, such like the caption of the images to describe what kind of pictures, what kind of classification pictures means. That's actually in a lot of the case in the web UI system, it's always automatically generating the prompt. So you don't need to worry about it, just keep it empty. So here I give this kind of short description and how you train your own neural model. And I will show you how to do that in our platform as an example. And here you can see this is our training mode section of our platform. And we'll start a new training. And here I will show you my dataset. I find some image of the Louis-Kahn buildings. And here is all my datasets. You will see they have kind of this similar style, but in different view and different color and different type of buildings. But you can clear to see they all have this Louis-Kahn style. I didn't choose so many pictures here, maybe 12 or 13 pictures. And I think it's enough to train this style. And here we just put all the pictures into the platform. And sometimes you can change the ratio of the pictures, just like this kind of tool. We can crop and resize. But in sometimes we can, or you can also skip that step. And we give a name. And we choose a basic model that's will generation the models later on. But we choose LX anything realist enhanced one. But you can choose any one you want because in neural model you can combine different kind of the base model. That's just related to the very beginning of the style. And we choose the style is rendering, and we will training the style and the trigger word. We choose a unique word, and just click start training. Actually, the whole process is done, and you need to wait maybe 10 minutes to get the result. it always needs some time, and yeah, still needs 6 minutes. Now the model will evaluate with kind of the prompts and the ratio, and we can just skip that. We will try to this model immediately, and we go to the start creation. And here is our model we trained before, and we plus the base model, and we try very simple one. And well, we will see the results of the model training. And you will see, even we have very limited description, and it already has kind of the features of the Louis-Kahn buildings. And we can try different things to check the model have this kind of the, let's see, diversity. Maybe we will try the interior. And we can also try some very strange thing to check the model can, if we can fit all this kind of situation. We try. We even can add some Zaha style. And here we see if we apply into the interior design, the feature is not so clear. So maybe we later will try this model. I will increase the training step and get the more clear result. If your model is training very well, it can fit not only the one you give in the exterior picture, it can also affect in many different types of the buildings or many different type of style. Now you will see if you use the Zaha Hadid style, but in the material and the kind of the texture is still use Louis Kahn buildings. So that means your model will fit in a wide use. And here is all my lectures today. And later you will try your own data on the platform to train your models. And if you have any questions, you can ask now.